Hello, welcome back to the channel Pharma Training Solution. So today we shall briefly talk about chromatography methods of separation of chemical mixture. So now what's chromatography? Chromatography is a process in which the chemical mixture is separated into individual components. Of course, separation of the fractions of the mixture is based upon a relative affinity towards the two phases of chromatography, where we have the mobile phase, which can be a solvent or a gas, and the stationary phase, which is usually a layer coated with an adsorbent. Now, of course, in chromatography we don't have absorption, but we have adsorption, interaction of the solid molecules with the surface of stationary phase. They are not absorbed, but they adsorb, just interact. What are types of chromatography techniques? Of course, we have paper, the older one, planar. These are older methods. Paper and planar. How we have TLC, HPTLC, column and gas liquid, or HPLC. And of course, the separation techniques, we have said one is adsorption. It could be partition, it could be ion exchange, or molecular exclusion. Molecular exclusion is based upon size. What I think here I forgot the description of the chromatography. The TLC, where we have a beaker with that TLC plate, where you put a line, and then you put the solvent, and it moves along on the TLC. What are the advantages of which you can find out? What are the advantages of thin layer chromatography? It is cheap, and of course the sensitivity is limited. It can be used to identify compounds and determine purity. Of course, as everything reference is in the pharmacopoeias. However, we have high performance TLC, which is usually automated, and it ensures better separation. The difference is here the separation occurs in horizontal tank, and the TLC, I forgot that diagram, I don't know why, occurs in a beaker, or in a beaker which is covered. So chromatography, of course, here is the technique in which components of a mixture are separated through a column. That column is usually packed with adsorbents. Separation depends on the flow rates. Of course, this flow rate also will depend on the affinity of each substance on the flow rate. As the component in the mixture which has high affinity to the adsorbent flows slowly, and that one which has high affinity to the solvent will flow with the solvent a bit quicker. Just define some simple terms in chromatography, like chromatogram. Of course, this is a plot at the end of chromatogram. We also have the rotation time taken for solid. Time takes a solid to move from the point of injection to the detector, rotation volume, and all those. This is the chromatogram, what I'm talking about. Injection point is the void, the unretarded solvent is the retarded. Now this W a half and H a half and here, these are used in calculation of this column efficiency. All these T's, it is rotation time. Now, what are the calculations in chromatography? Of course, as I've said, that void volume refers to the time it takes the unretarded molecule to flow through the column. Unretarded, you're having the solvent moving from point of injection to the site to the detection. Capacity factor, this is a measure of degree to which a component or partition adsorbs between stationary phase and from the mobile phase. This is the formula for capacity factor. Now, Column efficiency. How do we evaluate column efficiency or column performance? We use theoretical plates. This is just a simplified version of chromatography. Resolution, rotation time, rotation volume, asymmetry factor. That is the asymmetry we are meaning. How this one, asymmetry. Is it can it be divided into equal parts or no? So rotation factor, selectivity, and all those ones have formulas on how they can be calculated. So I want to talk about theoretical plates. Of course, now theoretical plates, this is imaginary. It has said theoretical. It is assumed that as the sample moves through the column, it passes through certain plates. Of course, in those plates, that's where we have an equilibrium between the sample, an equilibrium of the solvent. It is equal as it is in the solvent or the mobile phase and the stationary phase. It is just an imagination. But how is it calculated? N equals 16, rotation time, the W base at the bottom, as I said above, or you can use the W I have. Rotation time, peak width, and the middle, all these ones can be expressed in plates per meter. This is the equation which we can use, or we can calculate the height of the theoretical plate. You know what is the theoretical plate? I'm sure the equations and the calculations which I didn't go through. Now, gas chromatography. Of course, in gas chromatography, as the name suggests, gas here, the mobile phase is gas, which moves through the column at high pressure. This one is used for components that can vaporize without decomposition. This is a simple presentation. As I said, my diagrams, you can get better ones, but I think they are well presentable. HPLC, this high performance, of course here the mobile phase is liquid but moves through the column at high pressure. This is the common one in pharmaceutical industries and is automated. You have the solvent reservoir, the pump, the injector, the sample, the column, the detector, and the computer system. This is the waste collection. It is used in analysis of drugs and quality control laboratory. This one it is there in those pharmaceutical industries. Determining metabolites, however, it is readily automated, but of course it is complex and this is large amount of solvent, meaning that it generates too much waste and of course is expensive. So thank you very much for listening to me in this simple presentation on HPLC and chromatography techniques. I always remain Wilson. You can always contact us for more clarity. As always, these presentations are just short versions of the notes you have. Thank you very much.